Okay, we're starting chapter 8 now. 8.1, we're talking about similar polygons. Similar polygons, this should be somewhat of a refreshment. You guys know what similar figures are, similar shapes are. Okay, we talked about in chapter 4. In this lesson, I'm going to start way down here. I'm not even going to go back up. We're just going to start here and work our way down. Start with definitions. Similar figures. This should be, again, a refreshment. Similar figures are same shape but not necessarily the same size. Okay, same shape but not necessarily the same size. If I go and write an example here, I'm going to do triangles. If I have two triangles, a triangle, little triangle, and then, ooh, big triangle here. Okay, let's say those are similar figures. They have the same shape, but not necessarily the same size. Okay, to remain the same shape, they have to have the same angle measure, which means this angle measure has to be the same as that angle measure. This angle measure has to be the same as this angle measure. Okay, and so on. Those angles have to remain the same. Those are equal in angle measures if they are similar figures. Okay. Similarity transformations. Similarity transformation is a dilation. A dilation or composition of rigid motions and dilations. Yeah. I really just want to focus on the word dilation. Dilation means it's either getting bigger or smaller, and it's getting bigger or smaller by a scale factor. Remember scale factor K? We said, let's say this side is 2 and this side is 4. Okay, if it's 2 and then 4, its scale factor is 2 because we multiplied by 2 to get from 2 to 4. Okay, if this side was 3, we have to multiply that by 2, so this is 6. And if this side was 4, let's just say, and this side has to be 8. Okay, multiplying each side by 2 get their scale factor. Corresponding parts. You guys should know what corresponding parts are by now. If you don't, we're in for a mess. Okay. If you don't know what corresponding parts are, please talk to me. We'll get it figured out. Okay, and I'm actually going to talk about corresponding parts right here. Corresponding parts in the diagram, triangle ABC is similar to triangle DEF. So, order matters, right? Angle A has to be similar to angle D. Okay? It has to be the same angle. Angle B is the same angle as angle E. And angle C is the same angle as angle F. Okay? A, B, C, D, E, F. Corresponding angles are congruent. Similarity transformation also enlarges or reduces side lengths by a scale factor of K. So if this is A is right here. This is being multiplied by that scale factor to get to that side. Okay. Yeah, good. If two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor. So, let's say we had two triangles. There's one, there's two. Let's say these were similar figures, so these angles are all congruent. Yeah. Those are similar figures. But this side was 2, and this side was 5. So what's the ratio of this, of the similar figures? What's the ratio of their side lengths? The ratio is, I'm going to say, big or little, from little to big is 2/5. Okay, that's fair. 2/5. Little triangle to big triangle, 2/5. So let's say this side was 7, and this is x. And the question asks you to solve for x. How would you do that? Well, we've used that scale factor and set it up as an equation to solve for x. Okay, if I have my little triangle, side length was 2, I'm going to have my other side length of my little triangle, x, on top. Okay, and over here I had 5 on the bottom, so on my next ratio I have to have 7 on the bottom. Okay, order matters. How do I solve this? We have 2/5 equals x over 7. We do what's called cross multiplying. 2 times 7 equals 5 times x. So it's 2 times 7, we have 14, equals 5 times x, which is 5x. Divide 5 on both sides, we get x is equal to 14/5. That's setting up a ratio and solving for a side length using the ratio of side lengths. Okay? Here we go. I'm going to move on. We'll go through more examples of this, I promise. Okay, this theorem says that if 2 polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. Okay, so this is saying we can use their, the polygon side lengths to find the perimeter of each one. So for example, let's say we have a side length of 3 here and a side length of 8. So what's the ratio from little to big? Well, it's 3 over 8. Okay, easy enough. So let's say this perimeter, the perimeter of this shape, the perimeter, let's say that equals 20. Let's say that perimeter equals 20. How do we solve the perimeter from this perimeter of this shape? Well, we're going to set it up as a ratio as well. Okay, so 3 over 8. I'm going to call this x, the perimeter x. I'm going to call that x. If I have 3 on top of my little polygon, I have to have the perimeter of my little polygon on top, which we don't know is x. Okay, and I had 8, which is my big polygon, that's side length, was on bottom. I have to have the perimeter of my bottom, or my big polygon on bottom as well. Order matters. 3 over 8 equals x over 20. And that's all. 3 times 20, which is 60. We have 8 times x, which is 8x. And then solve. If we divide by 8, we should get x is equal to 7.5. So the perimeter of this little shape is equal to 7.5, based on our corresponding side lengths. And that's how you find perimeter using ratios of side lengths. Now, let's talk about area. Because areas is a little different. It says if 2 polygons are similar, okay, then the ratio of their areas is equal to the squares of the ratios of their corresponding side lengths. So the ratio of their areas is equal, but the ratios of their corresponding side lengths is squared. So let's start by this. Let's say, let's use the same numbers here. We have 3, we have 8. Let's say this area was 20. Let's just say the area was 20. And it's just, for example, easy numbers to work with. Let's say the area is 20 of that big shape. Okay, we're going to set up that somewhat of a similar ratio. We have 3 over 8 is going to be equal to, well, the area was x. X over 8. Oh, sorry, x over, not x over 8. X over 20. Okay, but this says their areas is equal. Okay, so areas stay the same, but their corresponding side lengths are squared. So we have to square its corresponding side lengths. Remember how we square ratios? Or square fractions? It's really like squaring both top and bottom. Okay, so if we square both, we get 9 over 64 is equal to x over 20. Okay, so now we have bigger numbers. I'm going to grab my calculator. 9 times 20, that's 180. So I cross multiply. 9 times 20 is 180. Equals 64x. 180 equals 64x. And I'm going to divide 180 by 64. You should get 2.8, around 2.8. Yeah, about 2.8. So it's a little different. The area is a little different. We have to square the side lengths. Square the ratios of the side lengths. Okay, down here we have some extra practice. And it says 1 and 2 of the polygons are similar. Find the value of x. Here's where order matters. So we have a small rectangle here. We have a small side. We have a long side. Yeah, these are similar. Okay, when we have a small side up here and a big side here. So I have to take 2 over 3 is equal to x over 7. And I can't really mess that order up any further. I can't do a different order. Okay? You have to do 2 over 3 equals x over 7. You multiply, you should get 14 equals 3x. Divide by 3, you'll get x is equal to 14 thirds. And I'm okay if you leave it as an improper fraction. I'm okay with that. Number two, same type of thing here. Okay, there's a number of different ways you can do this one because we have more than just two sides. And we know 3 sides on this triangle. We know 2 sides on this one. Okay? But order matters. So let's say we have a single angle and a triple angle. Okay, 25 here. Well, where does it go from a single angle to a triple angle? Right there. So we have to have 25 over x equals, then you could either do any one of these. We have single angle to double, so 20 over 8. Cross multiply, you get 20x equals 25 times 8, which should be 200. Equals 200. Divide by 20, you should get 10. Okay? Can I do this a different way? Of course. Of course I can. I can start by saying the triple angle to double angle, 30. Triple angle to double angle, so 30 over 12 is equal to, I have to use 25 and x, because that has x in it, right? So equals 25 over x. We have 30x equals 300. Right, x equals 10. Same answer, which is good. I should get the same answer.